Welcome back to another Chem Lab. Today I'm actually in my kitchen here at home because I think this was going to be a little bit easier to do in the kitchen than the Chem Lab. And this one, all you really need is a big old red cabbage, which obviously is in pretty much any grocery store, okay? So I expect to see all the red cabbages bought out of Payless next time I visit. Go get yourself a red cabbage. I would really recommend you try it. It's easy to do, it's fun, not hard at all, and it's just cool to see what happens when you mix this with a few things. Okay, so we're gonna eventually test some chemicals, household chemicals, and red cabbage can actually make what's called an indicator. An indicator is a chemical that will change color with different pH. Okay, I'm gonna cut this while I'm talking. And they're kind of unique. It's actually very complicated how those chemicals work. There we go. I always think they're so pretty. I don't actually like cabbage, like, very much, really. In a few things I'll eat it, but I do think they're cool how they grow. Isn't that pretty? And when I took botany class, I learned all about all the names for exactly, like, what this is and how it grows, and it's just kind of cool. But, yeah, okay? You don't need the whole thing. Probably about half, maybe not even that much. Will do the trick for you. But it is this really bright, it's called red cabbage. It's almost like a purpley, really, sometimes. And that's a certain pigment that is inside the cabbage. And that pigment is what we really want. So take your cabbage, cut it up a bit. You don't really need the big old stem in there. You can cut that out. And this is not super important how you do it. I'm just going to cut it up relatively small so that it's easier to boil down. There are two ways of doing this, right? And our goal is to get that purple color, that indicator, into solution. Okay, we also learned about solutions lately, right? And to do that, you can either boil it, or I think you can also just put it in a food processor and with some water and chop it up really fine, but then you have to strain it. You don't want the big cabbage pieces in there. You just want that juice. Okay, so chemical indicator changes color, and it's a pigment. It can do that. And it actually is often very complicated with why it changes color. It has to do with the chemical bonds, of course. It always has to do with chemical bonds. And just changing one little bond inside of that chemical can be enough to change how the light hits it. Okay, so if it hits it a certain way with the one bond, it'll appear one color. And if you change the chemistry, you change that little bond inside of there, it will appear a different color. And different chemicals will, different indicators will do it in just a slightly different way. So, we're going to finish cutting this up, and then I will come back. Wait, so this is probably too much. I don't think you need that much cabbage. I'm going to make more just so I can do a bunch of different experiments with you. But all you do, put it in there, add some water. Cover it up a little bit, and then we'll just turn this on here. And we're going to let that boil. Just give you a fair warning, if you've never boiled cabbage before, it does smell pretty significantly. So, you know, might want to warn your family about that first. But this will take a little while. You're looking for just a really thick, dark color to the liquid inside. Okay, so this has been boiling for maybe 10-15 minutes, maybe not even. And the cabbage has turned a little bit paler of a color. And the juice, I don't know how much you can tell, but it's a very dark purple reddish color. So once you get to that point, go ahead and turn your heat off. You're going to want something to strain this with. Pour that in carefully, don't burn yourself. You're not in the chem lab. Still need to avoid burns. Okay, you don't need any of the solids. So some people like to eat that. You want to eat that, that's fine. I'm probably not going to eat that. But let that drain a little bit. And then you're going to want to let this cool before you work with it. You don't need it to be hot. You want it to be pretty much room temperature. So I will see you again in the lab, and we will find out what this does. Well, it is the next day, and we are back in the lab here. This is the solution that I made yesterday and brought from home, and we're going to see today what we can do with it. So, it is a lovely purple color. It smells like cabbage. So let's see what happens if we mix this up a bit. and add vinegar. Okay, just regular household vinegar. Now, this I'm just going to do, it's called qualitatively, not actually measuring this out, but just pouring it in until we get a color change. So you tell me, vinegar. You actually should be able to tell me the chemical formula of vinegar right now. But what is it? Is it an acid or is it a base? And just pour a little bit in. Pay careful attention to, oh, look at that. So, pour it in, mix it around a bit, and very quickly we went from a purple to a pink-red color. Okay, with my eyes it looks like a bright red. Not quite, it has a little bit of pink in there still. Really pretty color actually. So that was with vinegar. Vinegar is an acid. Okay, so this is an indicator, the cabbage indicator. When you add an acid, it should turn red. And again, that has to do with the fact that the actual pigment inside that makes that cabbage this purple color, that was the color we started out with, okay, can change depending on the pH. And pH has to do with concentration of hydrogen ions. And those hydrogen ions are powerful chemically speaking. They can take something and change it and rip it apart. And so they take the pigment molecule and actually just change a little bond in there a little bit. That changes how the light hits it, and that changes what color we see it as, because it's a little bit different chemical. Okay, let's see what happens. I'm going to take just good old baking soda here. You hopefully have some around your house. And try adding baking soda. Baking soda is sodium bicarbonate. And because of that carbonate ion, it's actually a little bit of a complicated reaction, but it can act as a base. Okay? So, let's see what happens. If you watch the foam, as that foam went up, it actually went back purple. It started out as pink foam, and then the foam was turning purple. And if I keep going, and of course you get that lovely baking soda and vinegar reaction, you have gas being given off. Oh, it's pink on the bottom, it's purple at the top. Let's add some more. Can you see what color it's turning? It is blue. It's actually even a darker blue than my glove here. This is one of my favorite colors. Not necessarily like cabbage blue, but that deep dark blue color of the ocean sometimes, or the night sky. One of my favorite colors. So there's our original purple. And then it turned pink in the acid and blue in the base. And it's actually very convenient. Those are typical like standard colors for acid base. We often draw an acid as red and a base as blue, just so that you can visually distinguish them. But it really does turn blue in a base. Okay, I wanted to do a little extension on what we've done so far with a lot of other chemicals that I have here in the lab. And I would really encourage you to do this at home. Again, do it with whatever you're interested in. What solutions do you have? Do you have different chemicals in your house, in your garage? A fun thing to do with this is actually sports drinks, or really whatever you like to drink. You can do coffee, you can do tea, Gatorade, sodas. Are very, very interesting to see what pH those solutions have. And you can do it with your cabbage juice, okay? Now the ones I'm doing here, I'm going to do with a different solution just because it will have more colors and it'll be a little bit easier to see, but you can do it with your cabbage juice as well, and it's kind of fun because honestly, the colors from your cabbage juice are in some ways prettier. So I have a lot of solutions here and I wrote them down. This is straight hydrochloric acid, okay? So that will be kind of our baseline for what an acid is. This is just plain water. This is a sodium hydroxide, a base. Then we have hydrogen peroxide, H2O2, ammonia, tap water, so water that I have is not been purified. And then in the back here, MOM, which is milk of magnesia. Mom, it's kind of funny. I don't know if it looks like that. you may or may not use it. It's a little bit like a Pepto-Bismol or like a Tums kind of thing. You use it to settle an upset stomach. You can actually drink it. Don't drink too much though. And it sometimes can make your stomach feel better. This is Lime Away, which looks like this. Basically toilet bowl cleaner. There it is. Okay. And be careful with this stuff. This is pretty nasty stuff. You, if you are going to do it, and especially if you're going to use the cleaning, if you do it with just drinks and stuff, that's totally fine. But if you do this and use some of these cleaning fluids, you really need to have gloves or something on your hands. Even just a pair of rubber gloves will be fine, because they can, even though they're just cleaning fluids, they can burn you and they can get pretty bad. Okay, and then I have bleach, and then just good old hand soap and a little bit of water here. And so all we're going to do is put an indicator in each of these solutions and see what their acidity level is, what their pH is. So this is pretty interesting. You can do this exact same thing with the cabbage juice. I just wanted to do it really quick to show you, and I actually ended up getting more colors than I thought I would. So this is hydrochloric acid with the cabbage juice. This is just the cabbage juice and water. And then I knew it turned blue, but as I started to add sodium hydroxide, which is a base, look, I got a yellow, and then, oh, it turned back yellow again. Hold on. Maybe this is it was a bright green for a while. I'm not getting my bright green. It was a bright green, now it's yellow again. And then the blue that I got with my baking soda. So all of that is cabbage juice, guys, and with different things in it. I'd be interested to see, actually, if you do this, how many different colors you can get. So see how many colors you can get out of just cabbage juice with different solutions, and send me a picture. I'd be interested to see what your results are. All right, so let's add some indicator. Okay, the indicator I'm going to use today is called Bogen's Universal Indicator. And what they do with this is, you know, cabbage juice is not the only indicator. Indicator is anything that's going to change color with different acidity. And so they've mixed together a couple different kinds of indicators here, which is going to give us a big color change. Honestly, that cabbage juice is pretty good, but it has a lot more. Okay, so here is the color chart, and I'll show you that again soon. But you can take and visually match up the color of your solution with the color of the chart to see what pH you have. So let's give this a try. All right. Just need a couple drops and it should be good. This is our hydrochloric acid. Put this in there, you can really see it. And then water. Sodium hydroxide, which should be a base. These should be our controls, okay? Strong acid, strong base, and then your control in the middle. I pulled the other test tubes out from back here just because they were interfering with the color. All right, so let's keep going. So you can see acid, relatively neutral, and then base. If you match that up with our color chart, that's that acid's about a 4. This one, this is about a 6, so we can say it's actually not completely neutral. This is filtered water, but not necessarily purified water, so it's about a 6. And then this one over here, not all the way to 10, maybe between an 8 and a 9, somewhere in there. Okay, this one's hydrogen peroxide. And then we have ammonia. That's an interesting chemical. You think ammonia is an acid or a base. And then just regular tap water. So our hydrogen peroxide is a little bit acidic. It's not as bright pink as this one, maybe about a 5. So definitely an acid, not super strong. Ammonia, this one was fun. Look what a pretty color that is. It looks like the cabbage juice. But that would be maybe about a 9.5 to a 10. Might even be a 10. Very basic is ammonia. That's why we use ammonia as a cleaning fluid. It can has other things in it as well, but the base will help it to clean. And then tap water. And this one, you can see the purified water over here. Look how much of a different color that is. There is a difference between purified water and tap water, especially on Guam. Because we have limestone in our aquifers, it tends to be a little bit basic. So you can see it's not a 7, it's probably more like an 8, which is a little bit basic, as opposed to purified water that's actually a little bit more acidic. Water that you drink can have a significantly different range in pH. Sometimes that's why if you travel and you drink different waters, you may not feel good sometimes. It could be trace minerals in the water. It can also be just the pH of the water, that your body's not used to that, and when you make that change, you may not feel good for a while until your body gets used to it. Alright, last couple to try. I was curious, and so I tried this one. Sorry, I didn't put it on camera, but this is actually cafeteria water. And let me just show you something. So look at all those different colors. So this is the water from my house, which is purified, but we have like a water softener and a purification system for water at my house, and you can drink it, it's totally fine. This is cafeteria water. This is water straight from the sink. And if you look at them, they line up pretty nicely with like a 6, 7, and an 8. Just like that. So cafeteria water, when you guys are here on campus and eating your lunch, you are drinking good water, my friends. It's almost exactly 7. And my house, a little bit acidic at a 6, and the Guam water is more basic at an 8, might even be a little bit more than an 8, because of the presence of solutes and things from the ground. So, isn't that interesting? It's all water, and yet very different pHs. Okay, so this is milk of magnesia. Now this one might be hard to do because it is already colored. It's a pink because you're meant to eat it or drink a little bit of it to help your stomach out. They put a coloring in it, so it's a pink color, but we'll see what this turns it. Sometimes it's hard to see the color. And then Lime Away, this is toilet bowl cleaner. What do you think that color is going to be? Acid or a base? Yeah. This is also a gel. As I said, this stuff is, it doesn't want to mix all the way, but look how red that is. Toilet bowl cleaner works because it's actually mostly hydrochloric acid is what it really is. And it's in a gel format to make it stick to the toilet better and actually so it can sit there and eat through things. But that acid, you know how your toilet can get like a little bit of brown residue build up around it or a little bit of a discoloration on the porcelain? That's from different things in the water that filter out and stick to the toilet bowl. And so when you put an acid on there, that acid will dissolve away and eat away at the lime and things that have built up, but it won't affect the porcelain itself, okay? Porcelain's not affected by it. So we use a strong acid to clean. This is also why when you use toilet bowl cleaner, please be careful because it can really hurt you. This one's bleach. Now, what do you think is going to happen when I put something in bleach? So we get a strong purple color, but I'm going to leave that one sit for a little bit, and we'll watch what happens. Okay, so just for color reference, the milk of magnesia, I'd say about a 9. And the toilet bowl cleaner, I know the bottom looks yellow, but it's because it wouldn't mix for me. It's actually lower than a 4. It's probably about a 2 or a 1 in reality. And then the bleach, between an 8 and a 9, so it is a basic solution. And then soap. Let's do our soap. We get a bright yellow. That would be about a 6. So not super strong either way, which makes sense. You don't want to, you know, burn your hands out when you're using your soap, but a little bit basic, and that will help it to dissolve certain things better and to help you remove the grease and grime from your hands. And then this was our cafeteria water. So it's been a little bit of time, and I wanted you to notice what has happened to the bleach solution. It actually doesn't have much of a color. It definitely is not any of these colors. And so you might notice that happening if you do bleach and say to yourself, well, wait a minute, so what is it? Okay, is it an acid or is it a base? I do not know. It is that color. And of course the answer is that it's bleach. And bleach, the reason why that we use that to make your clothes nice and white, to clean things, to get out stains, and it's very effective at it, is because bleach can remove color. All right, so the color that was in this indicator solution was there originally. It was, I think, a dark purple, right? It was very, very dark color, but over time that bleach solution tore apart or ruined, denatured the chemical, and that chemical no longer has a color. It's actually still there, so the pigment is still in there, but it is no longer the same chemically. It's been altered a little bit, and that alteration is just enough that it no longer shows a color when the light hits it. Okay, the light just goes right through it. So wanted to just warn you that way with bleach. And there will be some other things too. If you try this out at home, you might find some things that you're like, hey, it's none of the colors. Maybe it didn't change or something. That just means it's not an acid or base. It might just be a water-based solution. It may not have any H pluses in it. If it doesn't have any H pluses in it, it's not really going to show up on an acid-base scale. That doesn't mean it's not dangerous. Okay, some people get the idea that if it's not, bright red acid, it must be totally fine, but that's not true. There are other cleaning agents, there are other dangerous chemicals. Acids and bases are just one of them. So, I do need to give you a final caution, okay? I have all these beautiful colored tubes, and here are all the ones from the cabbage juice, and then all these other ones we were doing, and they look like great fun. And of course, everyone always wants to know, at the end of the session, what happens if we mix all of them, right? And I need to tell you, do not do that. See all the beautiful colors? Do not mix them all together. I know it sounds like fun. Some things you can. I mean, if you tested all the sports drinks, you could probably mix those together and it wouldn't be a problem. But if you are testing actual chemicals from your house, do not mix them all together. Okay, it can actually be quite deadly, especially ammonia and bleach. Do not mix those with other chemicals. They can release fumes that can be quite toxic. If you're really interested, message me the name of the chemicals you've got and I'll tell you if you can mix them. Okay? So I really hope you can do this at home. It's a lot of fun. It's fun just to see what will turn what colors, and if you can get a full rainbow, how much you can get, it's really cool. So try it out, and if you try it out, send me a picture. Let me know how it went.